So we're going to do a day of review on geometric figures, specifically perimeters, volumes, areas, and surface areas. So in front of you, what I've got is some basic perimeter formulas for these often used geometric figures. Perimeter is basically the distance around a figure. So you're going to add up all the sides, and we know in a rectangle that all the opposite sides are going to be equal. So that's basically 2 L's and 2 W's. If we go around a parallelogram, it's also true that the opposite sides are equal, much like a rectangle, except we don't have right angles. So again, that's 2 of one side plus 2 of another side. Square, all 4 sides are equal, so the perimeter is 4 sides. Triangle, you may have sides that are equal, but not necessarily, so it's just the sum of 3 sides. In a circle, some identifying features of a circle is you've got the center right here. Diameter goes all the way across the circle, going through the center, and a radius is a segment going from the center out to the edge of a circle. Circumference, which is really a circle's perimeter, if you will, is 2 pi r. And we'll use the actual value of pi sometimes, which is just pi, we leave it as is, or sometimes we'll do an approximation of 3.14. So let's take a look at some problems here. I want to find the perimeter of a parallelogram with sides of 3.2 and 5. So as we talked about before, we have a parallelogram, something that looks like this. The opposite sides are the same, then we have 5 and 5 and 3.2 and 3.2. So we're just going to add all those up. So we have 5 plus 5 plus 3.2 plus 3.2. That ends up giving us 16.4 units. All right. Now this figure is a little more difficult. We're asked to find the distance all the way around it. It appears more difficult because you see here we don't have measurements of these two sides, but there's a couple things we do know. That these are all straight lines and right angles. This actually here is a right angle as well. So what that means is it means if I stop here at 4 and continue on in a straight line, then this segment here has to be 4 as well. Likewise, if I know that this side is 6.6, this is a right angle and this is a right angle, and it's 2 straight lines, then this also has to be 4 right here. So now I just have to add everything up. I've got basically 3 times 4 plus 6.6 plus 8 plus 2.6. So when I add these up, I have 12 plus 8 plus 6.6 plus 2.6. That's 20, 28, and 1.2 is 29.2 centimeters. Want to find the distance around a semicircle? Well, this idea of a semicircle, first of all, that's half a circle. So what we've got is we have this situation right here, and it said the diameter, which is that segment going through the center on both sides, is 10. So I know this distance here is 10. The radius then is half of that, which would be 5. And if we want to find the distance around that circle, then what we're going to have to do is find this curved distance and the straight distance. So what we really have is we have 10 plus the circumference. And then since it's a semicircle, we're going to have to divide that circumference by 2. So let's calculate the circumference first of all. We have 2 times pi times the radius. And the radius in this case is 5. So what we'll do is we'll go to our calculator and be as accurate as we possibly can. And at this point what we really have is we have 10 pi, but we're going to divide that by 2 because we have circumference by 2, which gives us 5 pi. So I can plug that directly into a calculator, and we'll take and hit our 5 button, and you'll notice there's a pi right above this little caret sign right here, which is the power. So I go second pi, and I get 15.707, and it's said to round to the nearest hundredth, so that's going to equal 15.71. So then I go back over here and I say, well, that's just 10 plus 15.71, or 25.71. That's the centimeters. We want to find the perimeter of the rectangle, or we know that the perimeter of a rectangle is 50. So here's a rectangle, and I know that its perimeter is 50, and the length of the rectangle is 12. So I know one side is 12 and another side is 12, but I have an unknown here and an unknown here. So what I know is I know that 12 plus 12 plus 2 of these unknown values are going to equal 50. And I want to find the width of the rectangle, so I'm looking for that unknown value. If I know 12 and 12 is 24, and this is 2 unknowns is equal to 50, then I know what I'm looking for is a situation where I have 24 taken away from both sides, since I've already used that, and I need to know what number multiplied by 2 is going to equal 26, which is 13. And we're doing this kind of intuitively without algebra steps, because that's going to come later. So when we talk areas, we're talking about the number of square units covered by the figure, so how much space it covers. And in a rectangle, we have the area being the length times the width. In a parallelogram, you'll notice there's a height to a parallelogram, which is perpendicular to a base, and that's just base times height. Area is also length times width of a square, except the length and the width are the same, so we call it the side squared. Triangle, 1/2 base times height. And here's our circle again, and that's equal to pi r squared. So let's go through and do some problems. We need to find the area of a triangle with a base of 15 and a height of 6. So let's say I have a triangle that looks something like this. Here's my 6, here's my 15. I know I have 1/2 base times height, so that's going to be 15 times 6. I know that 15 times 6 is 90, so this is 1/2 of 90, or 45 square centimeters. Now this next problem is a little more intricate in that we have to find the area of this figure, and you'll notice that we've got sharp angles here and there, and we can't necessarily tell exactly how many square units it is. What I like doing on these is I like creating a giant rectangle. And then I know that in this giant rectangle, its entire area is length times width. But then what I can do is I can subtract out the unshaded parts. So in this rectangle, I have 1, 2, 3, 4, 5, 6, 7 units on one dimension, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units in this other direction. In these triangles, notice what I have. I have a side of 2 followed by a side of 3, side of 1, 2, 3, 4, followed by a side of 2, side of 2, followed by a side of 1, 2, 3, 4, 5, and a side of 5, and a side of 5. So I'm going to subtract out those 4 rectangles. My overall area is 70, because that's length times width. So area of rec is 7 times 10, but I'm going to subtract out each triangular area. Let's start with this one. That's half of 2 times 3. I'm going to subtract out this bottom one, which is half of 2 times 4. Going to subtract out this one right here, which is half of 5 times 2. And finally, this last one here, subtracting out half of 5 times 5. So I have 70 minus half of 6, which is 3. That's half of 8, which is 4. It's half of 10, which is 5. And this is half of 5, or sorry, 25, which is 12.5. And overall, that's going to give me 45.5 units squared, because area is always in square units. Let's move on. I'm going to find the area of a semicircle having a diameter of 18. So this is a little similar to our last problem. Here's a semicircle. I'm going to take half the area of a circle. I know that the diameter is 18, so if I know the diameter is 18, that radius is 9. So we're going to take 1/2 of pi times the radius squared, which is 9. This gives me 1/2 of 81 pi. And it says we're going to take and find the exact value in terms of pi. Exact value in terms of pi is 81 over 2 pi. But then it says we're going to find an approximation for that answer. This is exact. In other words, it has the pi in it. There's no rounding and there's no decimals. And then to find the approximate value means we're going to pop that into a calculator. Once again, if we pop it into a calculator, we take 81, divide that by 2, get an answer for that, and then multiply that by pi, and end up with 127.23 if I round to the hundredths. So the approximate is 127.23. Alright, this next problem's much tougher actually, in that we have 3 different shapes and one of which is not a whole shape. So we've got a triangle, and I need to find out its base in order to find its area. I know this whole side of the rectangle is 8, and this little straight part of the rectangle is 3, so I know that this base has to be 5. So for the triangle, I have a half base times height. For the rectangle, I have base times height, or length times width. This top guy equaling 15, this second guy equaling 24. And then I have 3/4 of a circle. So what I'm going to do is take 3/4 of pi times the radius, and they gave that to us, times 3 squared. So what I have really is I have 3 times 3 from 3 squared times 3 is 27 over 4 pi, and I'm going to round that once again to the hundredth, because that's what the problem asked me to do. So I go once again, my calculator, go 27 divided by 4, enter to get my answer, and then multiply that by pi, giving me 21.21. This is 21.21. Add all those up. I have 39, 40, 50, 60.21. So total area is 60.21 square centimeters. Or not square centimeters, square units. Okay, let's move on. So when we talk about volume, we talk about space occupied. And for a rectangular prism, we're only going to look at two actual volumes. There's several we can look at, but we're going to do two today. It's length times width times height, which means this is like a box. For a cylinder, it's pi r squared times your height. And you've seen all these formulas before. We're just putting them all together today. So when I want to find the volume of this box that's 5 wide, 13 tall, and 4 long, I just multiply the three together. So I take 5 times 4 times 13, and I end up with 260. Now the units for this are cubic. So inches cubed, and that's how you say cubic inches. Find the volume of the cylinder. We're going to go pi r squared times the height. Now your radius is 4, so I'm going to take pi times 4 squared times my height, which is 12. So what I've really got is 4 squared, or 16, times 12, which is 192 pi. This is the exact value. Since it didn't say it around, they assume that you know to put it in exact value. Surface area, lastly, is the total area of all the surfaces of the figure. So there are fancy formulas for all of this. Sometimes it's just as easy to count up all the sides and find their individual areas. But for a rectangular prism, if I take two sides, the top and the bottom, the front and the back, that's two of your length times your widths, 2 of your length times your heights, and 2 of your widths times your heights. For a cylinder, in order to find the cylinder, you have to find this curved surface. So you actually have to split the curved surface up. And when you do that, the curved surface turns into a rectangle that is h high, just as the h is here. But if I split this rounded surface here, it actually takes the whole circumference and makes that the width of that rectangle. And then of course you have the top and the bottom. So as you can see, the surface area is 2 pi r squared. That's the top and the bottom, two circles. And then that curved area is that rectangle of a height by the circumference, 2 pi r h. So we're going to paint this cargo container, and we're going to paint everything except the bottom, so we want to know what the surface area covered is. So basically I have the front and the back. So area, front, back is going to equal 9 times 10, but I have 2 of those. I'm going to take the two sides, this side right here, and the side that you can't see on the other side. And those areas are, notice, 50 by 9. I have 2 of them. And it says we're not going to paint the bottom, but we will paint the top. So I have to take the top area and find that, which is 10 by 50. And then I'll take and add all those up. So I'll first take and say I have 180 here, I have 900 here, and I have 500 here. Adding all those up, I get 1580. And since this is area, we're talking about square feet. So now I have a cylindrical wooden block, and we're painting it yellow. So here's a cylinder, like such. And I know that the diameter all the way across is 10. And I have a height of 20. And we want to find the total surface area because we're going to paint everything. So this is straight plug and chug in the formula. Surface area equals the top and bottom, which is 2 circles, 2 pi times the radius. In this case, the radius is half of the diameter, so that's 5 squared, plus 2 times pi times the radius again, times the height, which is 20. So in this case, I have 25 times 2, which is 50 pi's, plus there's 100 times 2, which is 200 pi's. And then again, since it hasn't asked me to round anything, I'm going to combine these two. If I have 50 pi's and 200 pi's, that's 250 pi's. And that is my exact value.